How far behind am I now?
Super high.
Friday.
Yeah. Like, you're just a little bit, you know, like, need to explain my brain.
Where were you?
Friday I was with Impulse, and Monday I just didn't feel good, so I took a half day. I came back during sick leave.
I'm not,
We're going to pass my card.
They're supposed to do it.
Which one? Oh yeah, my.
No, Bonzi made
Your
it.
regular one.
Yeah, I know.
Oh, we did it.
Bonzi did. Yeah, we
I
did it.
get on my,
I was so upset.
I go home and like my hat's on.
Jasmine's card was down to me that night.
Really? Is that why she was at your house the same night?
No, they all stayed the night.
Oh yeah.
Oh, but then it broke down. My dad had to come home at 1 o'clock in the morning.
And Nick, how was that game? Is this stupid as you
I forgot my dad DJ'd that.
I
thing.
was home at 2:30. People woke me up. And I'm like, no, you're PE. Alright. What
How
did
much
you
are
do?
you paying
It's like the stupidest game ever.
Oh, is that what you were just talking about?
Yes.
Oh, I didn't.
Is it what I said it was, like end zone party or something? You throw the ball across the field, you catch it, pick up a bing bang, walk across the field, throw it in the bucket, and you try to get the score.
Are you serious? We can only have 4 people catch the ball at once.
What happened?
That sounds,
It's so good.
that is so dumb.
Who's ready to take some notes?
Yay!
Okay, alright, take a seat. Okay, here's what we're gonna do today. I have 3 problems picked out. I'm gonna go through these pretty quick. I'm gonna fly through these just to make sure you can kind of see kind of every type of problem that I'm gonna assign you today. I think it's pretty straightforward. We're gonna probably spend the most time on the problems we did yesterday. You know, where we have to do kind of everything to the problem. And we'll pick one out from the book and we'll try everything on it. Okay? Alright, so let's start with the first type, right? The first type of problem that I want to start with is the easiest ones. This is the one that I don't think I necessarily have to cover it, just because it's pretty straightforward, but I definitely don't want to leave you hanging just so you're not getting, silly wrong answers, that type of thing. Alright, so let's drag this across. Alright. So okay, so we have this graph. Notice we have some vertical asymptotes. The vertical asymptotes are at -3, 3. We probably have a horizontal one going right here. That's why these are kind of hugging it. So there's probably a horizontal. Remember, horizontal asymptotes, the graph can actually go through them. It's more of a guideline kind of where the ends are going to be going. So, in fact, we could come up with an equation for this, pretty straightforward, kind of a rough example. I'm not going to do that. Basically, the questions that they're going to ask you about this, they're going to give you a picture, actually a couple of different pictures, and they're going to ask you a series of questions about limits, like we did yesterday with the calculator. Like, for instance, the limit as your function of x, and this is a function, as x approaches -3 from the left side. Okay, so we're approaching -3 from the left, and x, so this is my x numbers, right? As we approach -3 from this left side, that's what this little negative sign means, right? It means from the left side. What number is your graph going towards? Boom, that's your answer. That's what you're going to have to put for the first couple. Like it's like the 1 second answer. So now they'll go, okay, what's your limit as x approaches -3 from the right side for your function? So as I approach -3 from the right side, that's right here. So I'm going to the right side. What is my graph doing? Going up. So where is it going towards? Positive infinity. Okay. Make sense? Okay. What about the limit as x approaches infinity, positive infinity? What is your function going towards? So now we're approaching positive infinity. So that means my x's are going in this direction, right? As I get out, way out, towards the direction of infinity to the right side, where is my function going towards? What number is it getting closest to on the y-axis? 0. It's going towards 0 on the y-axis. Here's the y-axis. Because again, what you're basically doing is you're reading off the y numbers. the y-axis numbers. So as I went to positive infinity, my graph is slowly getting closer to 0. That's what's going to happen. Okay, so that's what a limit is. You're approaching the left side, the right side, you're going towards infinities. All they want you to do is read off what those answers are, where your graph is going towards. So you're reading off where these blue arrows are going. So if they're going up, they're going to infinity. If they're going down, they're going to negative infinity. If they're hugging to 0, then they're going towards 0. Okay, any questions with the first couple of those? Does anyone need any more examples of that? Now, the only reason why I brought those up yesterday is because what we were doing yesterday in class is we were graphing these things by hand, right? Graphing fractions, rational functions by hand, and at one point in the middle of our graph, we had to kind of figure out where the arrows were going. So what we started doing yesterday was like plugging in numbers in your calculator into those fractions and seeing what the numbers were. And that's basically what they're doing here. They're trying to figure out, okay, the arrow's going up, they're going down, where are they going? Because that was the majority of how we graphed. It was basically guessing and checking. Do you think you could handle those if I give you, I don't know, 5 or 6 of them? There's something really quick. And plus, the best news is some of the odds on the backs, you can kind of get a glimpse of like how they're doing. So if you're not quite sure. Plus, you can always look at the book and see how they do for the actual sections you read through. Okay, all right, now, second type of problem. We're going to give you something like this. We're going to give you a function. Let's say it's x minus 4 over x squared plus 6x plus 5. Okay? So let's say that's my rational function. Now, here's the good news. They're not asking you to graph this. They're not. They're asking you one simple question on this type of problem. This will be the next couple problems you're going to do. Where is your vertical asymptotes? So it's not asking for, end behavior, x-intercepts or y-intercepts. Not asking for symmetry. It just wants to know where are the vertical asymptotes on this graph. That's it. It's a simple number or numbers. Okay? Vertical asymptotes, if you don't remember, vertical asymptotes are where this function fails. Like numbers you are not allowed to plug into that function. So, to figure out where the vertical asymptotes are, you need to factor the denominator. Factor that denominator up, and then we can figure out what numbers make the bottom 0. Because if the bottom turns out to be 0, this is where the function fails. You cannot divide by 0. So how do I factor that mess apart? What rule do we use when we factor those? Is it a common factor? Is it trinomial? Is it difference of squares? Cube rule? Grouping method? Which one? Trinomial. Right, that's a trinomial. So trinomial rule is 2 parentheses. The back symbol says that they're going to be the same. They're going to be both pluses. They're going to be plus plus. You break up the x in the front, x and x, and then how do I break up 5? 5 and 1. And that hopefully makes the 6 in the middle, which it does. And if that didn't work, you always do the quadratic formula. Negative b plus or minus square root of b squared minus 4ac all over 2a. That can give you your roots as well. But what makes these parentheses 0?
And your attention please to representative from athletic health is here. The expression is sophomore athletes who need to meet with us, you can report out to the library at this time.
Okay, say it again. Negative 5 minutes. Okay. All right. These numbers that you just found, those are where your vertical asymptotes are. That would make the bottom 0 and you can't divide by zeros. Do you think you can handle 3 or 4 of those? Just back to the bottom. That's it. Quick answers. Say it again? Maybe only 2. All right. Okay, those are vertical asymptotes. Now the second question would be, I'll go with the same function now. Maybe we'll do a couple of these. Where's the horizontal asymptote? Okay, horizontal asymptote now on the same function. So that would be like this. So you had a couple of those, and then it suddenly switches gears. You read the instructions. Says, okay, for the following problems, find the horizontal asymptotes if they exist, because sometimes they don't. Now, the 3 rules for horizontal, because vertical is very easy. Always back to the bottom, whatever the bottom is. That's your horizontal or vertical. Horizontal is there's 3 rules, and again, they print these in your books. You know them. If the top power is bigger than the bottom power, for like the greatest factor. Like top power is bigger than the bottom power for the biggest terms. You don't have a horizontal. Okay? But the top is bigger than the bottom, no horizontal. This one, is my top bigger than the bottom? No. We definitely have one. It's somewhere. There is a horizontal somewhere. Now, how this works. If the powers are the same, right? You divide the leading numbers out front. That tells you, so if these powers are the same, like x squared over x squared, you take 1 divided by 1, and that's your horizontal. It would be at positive 1, right? But we don't have that. My top power is smaller than the bottom. So if the top is smaller than the bottom, your horizontal asymptote is automatically at 0. Automatically. That's what we have in mind. Make sense? So, if the top is smaller than the bottom, it's automatically at 0. If the powers are the same, so let's say 3x to the 4 plus 9x all over 7x to the 4th minus 18, whatever this function is. Since the powers are the same, we divide those. So the horizontal on this particular problem, since we do have one, top power will be bigger than the bottom. So we definitely have one. You take the top divided by the bottom. You take the leading numbers. And this is where it's at. It'd be at 3/7, whatever that decimal is. That's where your horizontal is. Make sense? Okay, that's easy. Like, quick hand. That's by far the fastest. Yeah, a couple of those. Okay, so what they're basically practicing, how to interpret a graph, where the numbers, where the graphs are going, infinities or zeros or whatnot. They're asking you for verticals, they're asking for horizontals. I think there's a couple of problems where they ask you for slant, where the slant horizontal or slant asymptote is. How you do slant. Let's go through one of those. How we do slant is the top. Okay, for slant, you take whatever the top power is. So let's say it's x squared plus 3x plus 2 all over x. Now let's say it's x plus 1. Let's say that's what we're dividing by. Okay. So this is my function. How we know slant? Slant asymptotes are when the horizontal fails. So on this one, you agree that the top power is bigger than the bottom power for the first terms. So this doesn't have a horizontal, right? It failed that test over there, both of those. So what we checked for a slant asymptote is that the top power has to be bigger than the bottom power by the number 1. It is. It's 1 bigger. So now what you do to figure out where the slant asymptote is, you divide these. You long divide them or synthetic divide. On this problem, I could probably synthetic divide because this is an easy binomial. So the number that represents this is a -1. That's the number that represents the bottom. That would be where the vertical asymptote would be. And then I'll divide the top. The top is 1, 3, and 2. And I'll synthetic divide that. So drop this down, multiply by the number in the box, drop this down, multiply by the number in the box, add this down. It actually turned out to be perfectly divisible. Had no remainder, but it didn't matter. Didn't matter if there's a remainder or not. This represents the slant. That's the function for the slant. And what this represents, that's a 1x plus 2, right? So you go up in powers. So this function right here, this is a linear equation in Algebra 1 class. That's your slant asymptote. So if we were to actually graph this thing, the slant asymptote would be at, we start at 2, and it goes up 1 over 1. 1 over 1, up 1 over 1, because that's my slope. And this is where the slant asymptote would be. So the graph will not pass that. Slant asymptotes are very rigid. Nothing will cross it, ever. It's like a vertical asymptote. Okay, you can't. Horizontals are, they allow you to draw through them. But slants, you will not allow to. Okay, do you see what you have to do though?
And you only do that when the top part is bigger than the bottom.
Top is about bigger than the bottom by 1. That's when it has slant. You wouldn't, like if this is like a 3 and that's a 1, you wouldn't.
And then you synthetic divide them.
You synthetic divide or you long divide it. Depends what the powers are, right? Because if it's an x squared on the bottom, and x to the third on the top, you have 1. But this synthetic only works when their degrees are long. And whatever's left should be able to graph. It's just a linear. I don't even care if there's a remainder. The remainder doesn't make any difference. It's whatever this thing was. That's what you graph. slant. Slant takes the most work, but it's only in rare cases. It's very, very rare that you ever have something that's exactly 1 power bigger on the top. Usually it's really kind of random. Okay, questions with any of the, basically I've went through 4 types of problems so far. Okay, last problem, and we're going to pick one from the book. This is basically what we've been talking about since, last Wednesday in here? We've been talking about this stuff. The last one is where we have to put it all together. One problem, everything in it. Now, the one problem I want to do today, I definitely want to do a single problem where we actually have to put in a vertical asymptote, that type of thing, where we might have a slant. I don't know if we've done, I think we did slant last Wednesday. I don't know if we've done it since then. Obviously something like this. But I want to make sure that we know how to do it. Okay, so is there any questions, concerns about what I want to go through? This is one of these, where I put everything in a graph. Do you have a couple? Alright. Back. I'm going to just pick one from the book. It could be one of your homework problems, so it won't be backing them up, essentially. You have an equal chance of getting homework problems. Let's see, pick of these. Any of those. Okay? Pick any one you want. If it was one that we did yesterday, I might tell you to pick again. Okay, got one?
So negative 2 over x squared minus x minus 2.
Okay. This is my function, right? So the first step, we're going to put everything together. End behavior. End behavior on this one doesn't make sense. There's no variable on the top. There's no in the biggest degree on the bottom. So if there was like an x up here, you take whatever that x is, divided by this x, and you kind of see where it's at. What I mean by that, let's say that the power on the top is x to the third and x squared on the bottom, like the biggest degrees. I divide these in my head and go, okay, so now over 2, we took away 2 of those, took away 2 of those, so it's going to be x to the first over 1, right? This kind of tells me where the end behavior is, where the tails go. If it's an odd number, you know, tails go opposite directions. If it's even, the tails go up. But this, it doesn't make sense, right? There was 0 x's on the top. 0 x's on the top, and there was x squared on the bottom. That doesn't make any sense to divide that. Right? It doesn't make any sense. So what that's telling me is that probably the tails and the end caps, like on the end behavior, the tails going this way, probably flat now. They're probably level. That's what it's telling me. It just doesn't make sense. They're not going up and down. They're doing something flat. Okay? All right. X-intercepts. What makes the top 0? Is there any way that I can plug a number into an x up here that would make the top 0? No, nothing. There's no x's. Now, if there was an x up there, yeah, it'd be 0. There's nothing. There's 0 x-intercepts on this particular problem. Probably what happened, the graphs are either above or below, and they never actually touch the x-axis. Does that make sense? We'll never actually hit it. So no x-intercepts. Okay, now y-intercepts, we could definitely have a y-intercept. So for y-intercepts, what we have is you plug in, you know, the rule was you plug in 0 to all the x's in your function and you simplify that problem. So -2, you plug in zeros down here, and this turns out to be -2 over -2, which is 1. So we're hitting 1 somehow on the y-axis. Okay, makes sense for x and y-intercepts? X, remember, it's whatever makes the top 0. That's an x-intercept. Because if this turns out to be 0 on the top, then the y would be 0. That's the reason. Okay, so this thing still could be symmetrical. Could be, because of the way that we're hitting here. You know, we could be balanced right and left side. We'll take a look at that here in a second. How we check that, we plug in negative x's into everything to check for symmetry. Plug in negative x's into everything, like this, and we see does the top change? That's basically it. So the bottom, well, the top didn't change. The bottom turned out to be x squared plus x minus 2, right? And this is not the exact same thing we started with, and it wasn't the exact opposite of what we started with. What it means to be opposite would be basically this whole thing but you put a negative sign up front. That would be an opposite. We don't have that. So definitely not symmetrical. And in fact, we'll see that here in a second. So it's not symmetric. We'll see that once we do the X-Intercepts, or the vertical asymptotes. Vertical asymptotes. We'll see that. Okay, questions, comments about what I've done here so far? Okay, we've done X-Intercepts, Y-Intercepts, symmetry, the end behavior with the tails, what they were going. Okay, so now we got to figure out the vertical asymptotes. How we do that, we have to factor the bottom and see if it actually works. That bottom is actually factorable. We can actually factor that. It's a trinomial, two parentheses, it's going to go plus minus, how I know that. Minus 7 for that. Okay, so x and x. Then how do I break up the 2? Where do I put them? Negative 2. I have to put a negative 2 here and a 1 here. That way it'll make the negative 1 in the middle. This x squared, negative 2x, positive 1x, that makes negative 1 in the middle, and then negative 2. Okay, so what are the numbers that make the bottom zeros? Negative 1 and positive 2, right? That's where my vertical asymptotes are. So positive 2 and negative 1, and now can you see why it's not symmetric anymore? The vertical asymptotes basically made it fail. It's not perfectly balanced, and it's kind of shifted over a little bit. So we definitely have 2 vertical asymptotes. Now, how many pictures am I going to have to draw here? 3. Well, I know there's 3 pictures on this. Because for every vertical asymptote, you have to have 1 more picture than that. So we have 2 vertical asymptotes, so there's going to be 3 pictures. One picture over here, picture in the middle, picture there. They always have to be on each side of the vertical. So if there's 4 verticals, and I'd have 5 pictures going across. So we definitely have 4 pictures. Now, horizontals. Is the top bigger than the bottom? No. So we definitely have a horizontal at some point. Since the top is smaller than the bottom for the degrees of x's, my horizontal is at 0. That was one of the problems we did over there. The top is smaller than the bottom, so we definitely have a horizontal asymptote at 0. If the powers are the same, then you divide the leading number up front. We don't have it. Okay, questions about all the stuff I've just done here today? So we figure out horizontals. There's no slant. Slant is on the top part, bigger than the bottom one by 1. We don't have slant in this particular problem. And the last thing we have to do, now we have to do that limit thing with your calculators. So take out your calculators. This will be my last problem today. We're going to plug a couple numbers in and see where this graph is going. What I'm betting on, here's what it's doing. It's probably doing something down here. It's probably doing something here. It's probably doing something down here, or vice versa. Okay, that's what I'm betting on. This thing is not symmetrical, so I'm betting on we're going to have something kind of goofy.
We have the graph on the homework.
Yes. Only a select few. I think there was like 6 problems with graph. 6. I think. I'll have to look back. Okay. You good so far? Okay, here we go. So, to draw this, I'm going to pick a couple dots over here, a couple points in the middle, a couple points over here. That way I can get a sense for this drawing. This is where you need your calculator. So, let's pick a couple numbers over here. Pick something really close to the vertical asymptote, something in the middle, something far away. -2. Okay, we're going to pick -2. What's another number? -16. On the road and somewhere in the middle.
-7.
-7. All right. I don't know if those are exactly the spots. We're going to plug those 3 numbers into this function here, and we're going to graph where those dots are. That way we can get a sense for where my graph is. Is it above? Is it below? Where is it going as it gets closer to that asymptote? So we're doing limits as we do this. Okay, so I'm taking my function, which is this. Alright, this is my function. And we're plugging those numbers in. So we're going to plug in, let's do the -16 first. -16 squared minus -16 minus 2. Alright, so now I'm going to do this by hand. Now, if you're typing this in your calculator, for the love of God, use a lot of parentheses. Put parentheses on the top, put a big parenthesis on the bottom. That way everything's being divided. Because some people yesterday in like my 4th period, they couldn't figure out that they had to put a lot of parentheses there to make sure that the entire bottom was in one big parenthesis. So -2 is on the top, The bottom 16 squared is 256, plus 16 minus 2. That's a really, really big number down there, and it's negative 2 divided by that. So that is a insanely small number, but it is negative. So that means this number will be somewhere for negative 16, somewhere in this range, like right there. It's nearly 0. Okay? So now we're going to plug in negative 7. Yes, I'm doing this in my head as I go, and you could do this as well. Okay, so I'm plugging in negative 7s, right? Negative 7. So that would be negative 2 over 49 plus 7 minus 2. That is still a very small number, but not as small as the last one. So at negative 7, it's somewhere in this range. Okay, so it looks like it's going down a little bit, because this is a little bit deeper. Like not as quite closer to 0. It's a little bit off. Now we're going to plug in negative 2. Negative 2, so that's negative 2 over 4 plus 2 minus 2. So this is negative, basically it's negative half. You actually simplify it, which is somewhere in this range. So what's happening is probably doing something like this. So as we get closer and closer to this negative 1 vertical asymptote, where's this thing going? Down to negative 50. Okay, it's going down. Because I could tell. The numbers were slowly getting lower and lower. So that thing is going to drop. Because I can't pass the vertical asymptote. Okay, questions with how I just drew that? Again, just plug in a couple numbers to get a sense for where that thing is going. That's why I use the calculator or just do it by hand. Okay, let's go to the middle. Let's pick 3 numbers in the middle now, please. Pick some numbers in here. 1 and 4. Let's go into 4. Let's go like negative half. Negative 0.5. That way I can get a sense. I already know where the y-axis is. So I'm betting on it's probably up here. It's probably doing something where it's like going upwards. That's probably what's happening. Well, let's plug a couple numbers in here. So we're going to plug in negative half, and we're going to see what happens here. So negative half squared, negative half. All right, so this negative half squared is 0.25 positive. That's plus 0.5, and then subtract 2. I get a negative number, which that is 0.75 minus 2, which is 1.25 negative. That's a negative 2 on the top. So that is just that's a small number. 1.6. 1.6. So it's somewhere in that range, and it is positive, right? All right, now we're going to plug in the number 1. We're going to see what happens there. So I'm plugging in 1 now into my function. 1, 1. So that's 1 minus 1 minus 2. And this turns out to be negative 2. So that's a what? A 1. So we're going to plug that in. It would be here. All right. Oh, you guys got it? All right. So it probably did something like this. Maybe we should plug in another number. Plug in like 1.5. Let's see if that thing's going up. I have no idea what the thing's doing. 1.5 squared. 15 minus 15 is 2.25 minus 1.5 minus 2. So 1 is negative 1.25. And yeah, that'd still be positive. So yeah, we're good. It's still going on. Okay, so I did it right. Did something like that. Okay. And the last one. Let's plug a couple numbers in here. Let's plug like 3, let's go 8, and let's go 12. Plug in those numbers and see where this thing is going into that function. So negative 2, 3 squared minus 3 minus 2. That's negative 2 over 9 minus 3 minus 2, which is negative 2 over 4, which is negative half, 0.5. Alright, so that's negative 0.5 here, so okay. And we plug in 8, so let's do 8 now. There's 8 squared minus 8 minus 2, so that's 64 minus 8 minus 2. So that's 54, so that's negative 2, and that's over 54, so it's a small number, it's almost 0. That's in that range. And then 12 would be the same thing, it's even closer, so this is what I'm betting on. This is what it's happening. Because it was getting closer and closer to 0, so it was probably going the other direction. Okay, questions, comments about what this thing looked like? Again, you need your calculator. The good news is if you have a nice graphing calculator, Jack, you can type these in really easily. You just know how to use that y function to get a sense of those graphs. All right. Okay, questions, comments, concerns? Okay, now it's going to seem very weird. It's a little weird. I'm going to hand up some graph paper, and then we'll get to the homework. And it's going to seem a little goofy. I'm going to let you choose some problems. It seems a little bit weird. You've never done it before. Now you get to choose.
Any suggestions?
Pick ones that we've already done. Be a smart thing to do. Okay. Now, there's certain problems you won't choose, but there's certain problems you will. We've never done that before. So every class could have some different problems. Okay.
Oh.
All right. Anyone need one? Do you have any extra back there? Everyone's got some graphics. You will not need all of this. There's only a select few you're going to have to graph. Listen. All right. So here we go. Okay, I'm going to give you the first part of your homework, and then when we get to the end, you guys will get to pick. All right. So page 355. Okay, here's the ones you have to do, 9 through 20. Those problems are the ones that we did at the very beginning. They're going to give you a picture. They're going to ask you what's the answer when this thing approaches -2, okay, or -10. Where does that graph go? Okay, where is it rapidly approaching? Okay, so those are the ones you have to do. You have to do 21
And
through.
attention, please. Jamie from Athletico, he's
45
not
off.
ready for any juniors or seniors that need to see her.
These problems, I know it seems like a lot, there's not. They're asking what are the vertical asymptotes? What are the horizontals? It's really fast, quick answer. Make sense? Like, don't graph. You're not graphing any of those. Now, here comes the ones you want to choose. Okay? You have to choose 4 of these. Just 4. Okay? Alright, so I'm going to put these up here. Okay. So I have 8 problems up there.
So we have to choose 4 of them?
You have to choose 4 of them. So, let's say them out loud. 59.
Wait, that's actually like 52 we've done that. What's
So-
that one that we did up there?
No idea. Not so bad.
That's
So, we've picked 59. What's another? 52. Probably a good choice.
63.
63.
5.
Smart.
79.
79. Okay, there you go. Hey, there's your 4. Okay? Make sense?
When's due? Next
This is
Friday.
due.
That's a good point.
This is due Thursday.
What?
Thursday. Where are you?
Thursday.
Thursday. Friday.
Let me walk you through my life.
No, not Friday. Thursday.
Your
Hey,
basketball game.
the reason why Friday, or Thursday, I mean, I'm not expecting you to school on Friday.
Wait a minute.
Yeah.
Why is it
So,
so bad?
3 to 5 in the morning, 1 to 3 at night with 20-mile-an-hour wind.
I wasn't expecting school today, or
Let's go.
So, hey,
Oh, we
no, hey, that's my call and not the school's call.
Yeah.
So, hey, this is due Thursday. Now, here's good news. I gave you a bunch of odds, and we've already done 52. So, you should be able to graph those. The rest of those, you could probably get done in maybe 10 to 15 minutes if you actually work pretty hard on that 9 through 20, 21 through 35. Like, you worked consistently, you weren't taking breaks and chatting.
Wow.
So, the ones that are graphing will take the most time. Obviously, I picked odds, so you can check the back to see if you did them right. Make sense? Okay, those are your 4. Now, if you talk to the other classes, they may pick other problems than yours.
No.
Okay, because they'll pick 4.
we'll tell them to pick all the same problems.
Please don't. I want to see which ones they pick. Because they went through different problems than you guys did. Because they picked, like Spencer did, they picked their own problems out of the way. So they may have done 6. Okay? Questions?
Have a drink?
Yes. Yes.
What?
Yes.
No, I don't do that, but I'll come over there.
Wait till
I have to Archer today. I have to say.
I don't have that.
I was in Adventure.
Today, it's been a long day. I did 2 and
Well, I have to deliver a what? You gotta deliver a ton of everything.
Let's pick up today.
Yeah. That's
Me, you,
We turned
Yesterday,
21. on the whole last week.
I didn't do it last week. I didn't do it last week because of my
So I'm the oldest on the whole.
I'll sit on the varsity bench.
Ow! So bad.
What?
Wait, is
Oh, I don't know.
So, if she's
Hey, Taylor.
yeah. I know. So, if you
France will probably still be a thing. Yeah, either way it's going up. Yeah, just gonna be fun.
So why is it not split?
I thought I almost froze that. What the?
You have a pound coffee right there.
Yeah, that's right. Poured it.
Oh, that?
Yeah, I poured it in the cup. I bought that this morning so I could get that through.
You just put it right there and it like warms it.
You live off coffee or
Yeah, pretty much.
or can we get a few mustache?
What?
Curl your mustache.
Oh, if I shave it, that'd be better.
You should do it, whatever.
Right there.
Water's talking to Are you going to agree on there?
Hi guys. You're doing a graph that right first.
Yeah, I know, thanks.
Alright, when I get one left, you're looking at plank.
Sorry, I didn't
Hey, those are good questions though.
This is the other side, the opposite direction.
No, you are.
Oh.
When I go to PE for spirit, I'm about to see a human
Down there?
Just see a guy. All I'm gonna see is good with the side, take out his chest.
It's gonna say shaft, or it's gonna have just an L.
He's gonna have a big L.
It's gonna be on the back, it's gonna say spin. I was bringing on a.
Front says L, back says spin.
What's the L's backwards in the front?
He did not.
Human chandelier.
That's not as bad as
Positive, I'm going this way. It's not negative.
Put out the batteries tonight.
Is Schmer even that good? Who did play?
Wait, no, we're.
Yeah,
Oh,
we're Zach, you're on
we're-
biggest post.
Yeah, but he's like 5'2".
No, they
We got one more too short.
Yeah, I know.
Kind of.
Yeah, more like that.
I remember what happened. I'm sorry,
He started to say something.
Hey, if you tried to check online for the video last night, apologies. I'm still processing the video. It took a lot longer than I was expecting. I'm on the last video processing it right now, so I was not expecting it to take that long.
Any bad stuff?
Doing 2 cameras at once was not a smart idea.
Yeah.
Get it? You know,
My phone.
See, you
Oh, why?
might as well get one class.
They say you need
Hey, I'd rather have them over you two.
Where are you, Connor?
What?
There's Gord.
what do you say?
I said I'd rather have symmetric data than my social security.
It's true.
Rude.
You'd rather have what?
She'd rather have.
Okay. I was in your group once. We didn't work together. We were a family. Wait, was that? Were you in there? I don't know. Yeah, we were a family.
So easy.
Yeah.
No, but like, okay, so if Abby, I can guarantee if Abby went out, she'd rather have it super easy.
Yeah, actually, psych is less important. Because I work in social science class, but we do like a lot of we take like a
Jack, I'm literally on my phone 24/7.
Yeah, she's in the front row, like, really on her phone.
You were on your phone the whole time during lunch class. I was like,
And then she'll like yell at Riley. That's the girl.
Policy?
Yeah.
Jeremy just watches
movies in class.
Jeremy always has his headphones on, and she doesn't say all the words.
Yeah, Connor says that he watches
Stu.
Netflix in that class.
Dude.
Where's
Put it on my
Rob?
face. I
Like,
got
she
your
doesn't
phone.
even care.
I'm thinking of moving to that desk in front of me. That desk gets so lit.
Oh, yeah, sure.
Guys, I didn't know we were supposed to go on this
Oh, yeah, I haven't
I
started.
didn't either.
That means we're gonna go to Paris and we're like snow the
I was down there.
Let's do it. No, I'm changing my mind. We're going to your house.
Alright,
I didn't shoot these.
Gord, what are you doing? Now the last thing was Brady's from like oranges.
So good, you break your phone.
I'll look at
What do you do?
Clean out my face.
Working at a bunch of dirt around. That's why I was in charge of the connections and make connections.
Lord.
Later. Have a good one.
Alaska, California, Colorado, Oregon, Massachusetts, Nevada, and Washington.
I still don't understand anything. We go over it all the time.
Would you rather too much or not at all? You guys, I can't find a happy medium. You guys complain that no one goes over. You complain that I go too much.
3 days was too much for one thing.
You guys come on.
It's not just Boise paper.
You guys are just complaining.
Complaining about
I'll try that next time. I'll do one day and now it's going to be one more day.
No, that was algebra 2 last year. Let's not do that. Oh, that was every day. I didn't mind sports.
I did. I never did homework.
Because I punched him in the arm. What? She's gonna go tell on me because I punched him in the arm. So I get suspended. Okay.